I think let's go ahead and let's get started with some of our experiments today. Today we're going to be talking about the ocean. And I don't know, I guess I'll ask you, all of you, have you all been to the ocean or been to the beach before? Maybe have you ridden on a boat? Have you ever been to the seashore? And even if you haven't, I think you might know the answer to the question that I'm going to ask. Oh, it says that some of our friends, sounds like some of our friends have been. That's perfect. So some of us have been to the beach. And what we're going to be talking about is what we see at the beach, the main attraction, which is the ocean. And here's my question for all of you is, does the ocean move? Because we know that the ocean is a huge kind of body of water. Does it just kind of sit there like water in a bowl? Or does the ocean move? What do we think? Sounds like we have some friends in the chat saying, yeah, it moves. What do you think? Does the ocean move? What are some ways that it moves? What do you think? When we think of the ocean moving, what kind of images are we seeing? What kind of words are we thinking of? Ooh, we think maybe it moves in waves. Okay, so waves are one of the ways that oceans move. Any other ideas? What do you think, friends? Oh yes, the big splashes. I love this idea, right? So splashes are something we think of. It moves in big waves, sometimes little waves, sometimes huge ones. There's lots of different, ooh, this is good. We have tides, ooh, and we have a friend saying that continents help kind of move the ocean around. Those are all going to be some things that we're talking about today, some different things that move the water on our planet's surface, our oceans. So our main things that we're going to be kind of talking about that move our oceans are many of the things we already said. Wind, water density. So that also has to do with the water's temperature, how hot or cold it is, how much salt is in it. The tides are something that also move our ocean. The Coriolis effect, which means the way that our Earth rotates, the way that our Earth moves in space, that affects the movements of our oceans. And of course, the way that land masses or the continents, as well as the shape of the sea floor, also move our oceans. So we're going to be mainly, in our experiment, we're going to be talking a lot about wind and about the continents and about those land masses. But before we did that, I wanted to kind of show you all kind of a demonstration that I think you all could do after this. But I wasn't going to do with you all on the show because it involves different temperatures of water. So I wanted to demonstrate these for you so you could see some of the effects, because I wanted to show you how both temperature and salinity, the amount of salt, change how water moves. So I'm going to go to experiment cam. We're not going to start our experiment yet, but I wanted to give you a little demo first. We're going to start by talking about temperature. I've got these two different cups here. This one has some blue food coloring. This one has some red food coloring. What I'm going to do is I'm going to have these cups filled with cool water. That's going to be our blue water, of course. And then I have some hot water. And that's going to be our red water. Now I have a question for you all. If I were going to combine these two colors of water, one of them is cool and one of them is hot, what do you think that they would do? What do you think if we combined these together and poured them into one, say, bag? What do we think that it would do? Do you think that they would immediately mix together? Do you think that they would stay separate? Give me some of your ideas in the chat. While we're thinking about it, what I'm going to do is create a little kind of testing chamber out of a plastic bag here. I'm going to take a clothespin and separate this bag into two. Again, this is a really cool experiment that I definitely encourage you all to try out on your own after the program. I just didn't want us to be messing with, I didn't want you all to have to mess with different temperatures of water while we were on and talking together. So I've got my two chambers of water, and we're going to pour the blue water in one and the hot red water in the other and see what happens. We have some really good thoughts in the chat here. We have some friends thinking it's going to turn purple. Maybe there's going to be a water or a color change in the water. Maybe they're just going to kind of mix together. That's a great thought. Let's find out what happens. So what I'm gonna do is I'm gonna fill our two sides here, each with our different colors and temperatures of water. So here's our cool room temperature water. I'm gonna kind of seal that up in there. You can see that my clip is keeping it from getting to this side because I want to combine these very gradually. If I just poured them into each other, I don't think they would have the same effect because they would combine very quickly. I want to see what happens if we combine them slowly. Putting my nice warm steamy water in this one. And we're going to see what happens when we mix these two temperatures of water, right? Kind of cool and warm. I'm going to go ahead and switch back to my face cam so that we can kind of see it against this light background here. What I'm going to do is I'm going to remove my clothespin and we're going to see what happens when this water mixes, right? So I'm going to go ahead and take that out and you all tell me what you notice. Here we go. Ready? We're going to mix them. What do you all notice happening? What do you think? Did they turn purple? Did they mix all the way? Yeah, they're kind of stacked together. Yeah, the hot water is on top and the cool water is on the bottom. What this tells us is these waters have different densities. Something is dense, it's going to be the one that sinks. So this cold water is denser than this hot water. And I'll tell you, right, so this one didn't mix, and I'll say that if I did mix them up, of course they would turn purple, right? But if we're mixing them really slowly and they're not able to kind of all swish together like that, they stack on top of each other with the denser, heavier, I guess you could say, cold water at the bottom and the less dense hot water at the top. Think about our oceans. They're all different temperatures, right? The water closer to our equator is going to be much warmer than the water that's closer to the poles, right, the North and South poles. So that's one way that when these waters meet each other, the cold water is going to be going underneath the hot water, kind of pushing the hot water up because it's less dense. That's one of the things that's moving our oceans. Let's test just one more and then we will get to our experiment together. So I'm going to put us on experiment cam here once more. There we go, wiping up my space. We tested temperature, and now I want to test something else. We're going to take a look at salinity, or the amount of salt in the water. So I'm going to take, has some yellow food dye in it. I'm just going to have some regular, like room temperature, yellow water. And then I've got some water here that has some salt in it. I'm going to put just a little tiny bit more salt in this. So I've just got regular table salt in here. And I'm going to put some water in here and stir it together so I can make some salty water. I've got some fresh water and some salty water. And I think that I'm going to make my salty water a different color so that we can see if there's a difference. So I'm going to make my salty water green. Now, that last experiment, something kind of unexpected happened, right? Where they didn't, when they were allowed to mix gradually, they didn't kind of mix together right away. The warmer water was kind of pushed to the top while the colder water sank to the bottom. Do you think that something similar might happen if we mix these two things in that same way? Do you think that one might rise to the top and one might sink to the bottom? Tell me what you think. We're making our own hypotheses, our scientific guesses here. Doesn't matter if we're right or wrong, because in this experiment, we get to find out the answer, right? We're just thinking, what do we think might happen? We have one hypothesis in the chat here saying we think green on bottom and yellow on top. We have another prediction that the salt water will go on the bottom, so that'll be green on bottom and yellow on top. Ooh, this is a great thought. I love this thought. So what I'm going to do is the same thing as before. I'm going to kind of create those two different chambers in my bag, like that. And I'm going to put my fresh water, my non-salty yellow water, in one. And I'm going to put my salty green water in the other one. All right, go ahead and seal that together. And now I'm going to switch back to face cam just like before, just because it was a little bit easier for us to see that. What we're going to do now is we're going to combine these two colors of water and see which one is denser, which one will sink and which one will rise. So a lot of us were thinking green on the bottom, yellow on top. Let's see what happens. Slowly mixing them here. Let's see. Whoa, you guys made a correct hypothesis. I think you're right. I think that that green salty water sank while that fresh yellow water rose to the top. It's kind of shining on my light here. Let's see if we can see it a little bit better like that. Oh yeah. So the salt water was denser. It kind of was heavier than the fresh water. So it sank to the bottom. The North Atlantic Ocean is saltier than the Pacific Ocean. So think about it, when those two types of water are meeting, it would cause one of them to sink and one of them to rise. So that's another way that water is going to be moving around the surface of our planet. There's a lot of things that make water move. Our oceans are really dynamic. They move so much. And I think next, let's check out a different way that water might move on the surface of our planet. We're going to do that with the materials I let you all know about. I've got kind of like a flat bowl. In my house, we call these blates because it's like a mixture between a plate and a bowl. We've got the shallow bowl. I also recommended like an upside down frisbee because that's something that has that's very shallow, but it's very flat and round. You could also use any kind of container, would totally work. I spilled a little bit of my water over here, so I'm going to mop it up before it gets on anything. So you've got your plate or your container. You've also got some water. Doesn't have to be any special temperature. Mine's just room temperature. We've also got a straw because we're going to be using our body's wind, right? Our breath to represent wind and its effect on the surface of the water. We've also got some food coloring, and that's to help us see the way that the water moves. Mine is actually liquid watercolors, but regular liquid food coloring would be just right. And I have some different kinds of rocks. I've got a couple here that I'll show you when we go back to experiment cam. But the idea is that we've got some different rocks. Maybe you all were able to find some. And these are going to be our continents, the different land masses, because right, the Earth is not just a bunch of water. There's also land on the Earth. And I think that we might find that it changes the way that water moves. This is a really great thought in the chat here. We have some friends who are thinking about animal adaptations for the bottom of the ocean, how to handle higher salinity at the bottom. That's such a great thought. I know there are a lot of adaptations, especially when it comes to color and different colors in order to be less visible at lower depths, and also to deal with the differences in temperature, right? Because we're going to tend to, in most spots, be pretty cold closer to the bottom. So these are some really great thoughts. Let's go ahead and let's create our model Earth together. I'm going to go ahead and switch to our experiment cam again here. Here we go. Here is my plate. And if you've got your plate and you're going to do the experiment with us, go ahead and put some water in your Earth. You don't have to fill it all the way up. I've got, maybe a quarter of an inch or so, not a whole lot of water. I've got my water here on my plate, and I'm going to add my food coloring in just a second here. And before we start with our rocks, before we put our rocks in, I want to do an experiment that's just water and wind. So what I'm going to have us do is I'm going to have us put our drop of food coloring right in the center, right at the equator area, and just do one drop for now. And then you can take your straw and you can position yourself at one of the poles. It can be the North Pole or the South Pole. And actually, if you've got more than one person participating, it's even better to have one person blowing from the North Pole and one person blowing from the South Pole. That could be really cool. There's only one of me, so I'm going to blow from the South Pole, and we're going to see how the water moves. I want us to be thinking in our heads before we start, what do we think the water is going to do? Do we think that we're going to see this food coloring and the water bounce around all crazy? Do we think it's going to go in a circle or in a line, or that it's going to look like ripples? We're going to go ahead and get started with our experiment, so you don't have to mention it in the chat, but you can definitely think about it so we can test your hypothesis. Ready? I'm going to kind of be right here near the South Pole, and I'm going to start blowing. Now, I don't want to blow too hard because I don't want to blow my water out, but here's how I'm going to blow, like this. I'm going to do one more breath. Ready? Now, I don't know about what you guys were able to see, but what I was seeing when I did mine is that the water tended to move up, and then when it reached the end, it kind of bounced around and came around like this. But it was a pretty good, it was kind of like a pretty straight line that then curved around. And that's because this was all water, right? Now I want you to think, what would happen if we put some rocks on our plate? Go ahead and let's think about, what do you think would happen if we took some rocks and had those rocks be our continents? So if you'd like, you can go ahead and create your little planet here. I know I'm creating mine. You can use your little rocks and put them kind of wherever you want to mimic the continents on your particular planet. I've got some different ones here. Maybe I'll put a little one over here. What do you think, friends? Do you have any ideas about what might happen? Ooh, I'm even gonna kind of put those two together. Do we think that the water is going to move in the same way? Do you think it's gonna kind of go straight and then curve? Or do you think that the rocks will affect the way that it moves? What do you think? I think the rocks are gonna make a difference too. Yeah, I think that's a good thought. And of course, there's only one way to find out, and that is to test it. So now go ahead and take your food coloring, and we're gonna give it like 2 or even 3 drops, kind of right at the equator again, right at the center. Ready? 1, 2, 3. And this is gonna be darker so that we can see it, since our water is already maybe slightly colored from our food coloring. Now, let's go ahead and take our straws, and we're going to create that wind current again, right? We saw how how blowing on the surface of the water, right, or the wind on the surface of the water did move the water both above and below, right? Moved the surface, had a surface current, and it also affected the water closer to the bottom of the container. Now let's find out the difference that these continents are going to make. I'm going to go ahead and get ready. You can go ahead and be at one of your poles, or if you have more than one person, you can be at both poles, and I'm going to start blowing. Ready? Here's my wind. Now, since I gave it a big breath, I can kind of watch it move even though I'm not blowing it. And I can see that it moves a little differently around where my rocks are. I'm going to give it another kind of big breath so we can get it moving again and watch the way that it moves. So we notice that it's very likely to, right, move almost a little bit faster where it's touching a rock because of the way that the rock is pushing back against the water. So when it's moved by the wind's energy, it's moving past our different coasts of our continents, and it's kind of creating a stream around those continents. We can see that depending on where it is in its path, it'll swirl in different ways. And this is similar to how we see different swirls of current happening on our own Earth. And I think I'm going to do just one more drop here so we can see these effects right before we go. right? We can see how it changes the way that the water flows. It can't just flow in a straight line and then move around in a straight line and move around anymore, because it's bumping into these land masses. And that's going to change the way that the current is moving. You can actually even see it's made kind of a cool path here. These are kind of similar looking to Earth's own currents, which I highly recommend you check out. Different kinds of current maps, especially like the NOAA maps, which I can put a link in the chat here in just a second. They have really, really cool maps of the different currents on Earth. They look really beautiful. I love, this is a really great thought. We have an extension for our experiment where we're gonna try it Pangea style. So we're gonna have a bunch of rocks to be one super continent instead of a bunch of smaller ones. That's a really great idea. I can't wait to hear about how it goes. So friends, that was a few different examples of how we can kind of experiment with the different ways that our dynamic, our moving oceans are affected by different factors, like wind and land masses and all kinds of different things. I hope that you'll give them a try yourself if you haven't already. I hope that I can see you maybe next week. I know next week we're going to kick off Black History Month with our special Black Excellence in Science program, where we are going to be making our own microscope. That's going to be a really cool one. Thank you all so much for checking this out with us. I really enjoyed doing it with you, and I hope that I might see some of you next week or the week after that. See you later, friends. Have a great rest of your day.